Let's take a pause and take a moment to talk about encapsulation. It's a super important concept in object-oriented programming. And if we just review what we got this dog class. It has a couple of properties. There's 2 public properties and there's 1 private property. We already covered these. There's 2 methods here. There's a speak method and an is hungry method, and one's public and one's private. And the concept of encapsulation deals with what information, properties, or methods are you allowing access to outside of your class. The answer to that should be the minimum properties and the minimum methods to have a functional class. So right now, we're allowing access to the age and the name outside of the class, and we're allowing access to this speak method outside of the class. And down here, you can see how we're using those. We instantiate a new object of that type, dog, and then we use the 2 public properties to set the name and the age, and then we call that public method called speak. And our output was over here. And so you can see it says Fred says whimper. That's when we say speak. And then our dump method is dumping out the object in this format so we can see all the different properties and if they're private or not. And for now, I'm just going to go ahead. Let's clean up this. We don't need this echo anymore. Let's get rid of that. So really what I have is I have 2 sections. I have a blueprints or classes section, and I have this instances or object section. Now the only reason that name and age have to be public at this point is we need a way of setting those properties outside of the class. So when we instantiate a new dog, every dog will have its own name and its own age. Right now we have this private property called food and belly that we instantiate, and so far we've been changing the value by hand, but we do need a way to access this property. So right now this property is inaccessible outside of the class. So outside of the class we can't set it. Now there are coding ways that we can actually do this, and they're called getters and setters. So for example, the food in the belly, I could write a public method. So public function, that's the method because it's inside the class. And there's a convention to naming these. The convention is we would say get, I'm doing camel case, and then we would put the name of the property like this, and we would just return that property. It understands that this property is an int, so it does want us to specify the return value here as an int. And now this is a getter for the property food and belly. So I can't access it directly, but what I can do is I can access it indirectly like this. So down here, I can define a variable called food, say level, and I could use that public getter to get the food level, and then I could echo it out. So if I rerun this, now I see it says Fred says woof woof, and then I have food level of 5. Now this speak method right now, it looks like I'm not adding any BR, so I might as well put a BR in here so we can at least get a line break. Let's do that. And we'll do a quick rerun just to make it more clear. So now it says, Fred says woof woof, that's from the speak command. So under it I get the food level. That currently is set to 5. Then I echo out the food level. So you can see that right there, food level is 5. This is a public getter for this private property called food and belly. Just like we have a getter, we could also have a setter, and it has the same convention for naming, but we start with an underscore set, and then we would just set the value based upon whatever parameter we feed in. So you can see here's a setter for the food in the belly. It takes an integer, and then we're just going to set our food in the belly to whatever that value is. So for now, down here, maybe I'm going to say, right before we get the food level, I'm going to set the food level, and I'm going to set it to some value that we haven't seen for, maybe it's 25. And up there, I know we've set a max, but we'll deal with that in just a second. So I'm going to set this to 25, and I'm going to rerun, and now you can see the food level says it's 25. And one reason why you may want to have a setter as opposed to just allowing direct access is to enforce some constraints. And so we said early on in our class that 0 is hungry and 5 is full. So here on the outside, I have fed in a number that violates our intention. Our intention is 0 is the minimum, that means they're hungry, and 5 is the maximum, that means they're totally full. One of the reasons why you may want to have a setter as opposed to just allowing direct access to this variable is here we can enforce those constraints. So for example, I can say that this variable, which they're feeding in the food and belly, is the maximum of either 0 or whatever they fed in. And then I can also say that this food in the belly is the minimum of whatever it is at this point compared to 5. And what these two things are going to do is they're going to constrain this to something greater than 0 and something less than 5. So if I rerun this now, we're feeding in 25. And if I refresh this, you can see now that the food level is constrained. It's capped at 5. I used a setter to add additional business logic so that I can constrain that input. And you can have a setter and a getter for any property. I could just as easily make name private and then have a setter for the name. But I'm not going to do that in this case. I'm going to leave it public, and I'm going to clean these getters and setters up because we don't need them. But I still might want to have something here that updates the food in the belly property. Maybe I have a public function called feed, and it's a void function, so it doesn't return anything. But what it does is it increments the food in the belly. So in here, then I can say if this food in the belly, if it's less than 5, we're going to allow this to be incremented. And we just say ++ here. Otherwise, it won't do anything. So now externally, I don't have this setter that says set the food in the belly. That's unrealistic for a dog. The action or the method would be I'm going to feed the dog. I'm going to clean up down here. I'm just going to say get rid of this. We'll get rid of that because we don't have access to that anymore. But what I'm going to do is I'm going to dump the dog here, and then I'm going to feed the dog, and then we'll dump it again. So I'll end up with 2 of these objects being printed out. So I'm going to go ahead and refresh, and you can see I get my 2 objects. Initially, the food in the belly was 5. After I fed them, the food in the belly is still 5 because it has this constraint where we're not going to add any more food in the belly if it's less than 5. So I'm going to set it to 0. So initialize it as a hungry dog. Refresh this, and you can see initially it's a hungry dog, and then after I fed it, I've incremented that to a 1. Right now, we have this method down here that's called isHungry. And this is private right now because there's no need for anything outside of the class to know if the dog is hungry at this point. Now we could do something like this. I could make this a public method. So now I can tell if the dog is hungry from the class, and then I can write logic now outside of the class saying if this dog is hungry, then go ahead and feed the dog. And just to see that we're feeding it, let's go ahead and move one of these dumps to right above this logic. It's like that. One's after. And I'm going to get rid of this extra feed. We don't need that. And let's see what we have now. So the only thing I've done is I've made this method, which was isHungry, available externally. So now it's part of the information that I'm exposing from the class. And I'm going to feed the dog if it's hungry. So let's refresh. You can see that the dog started off with no food in its belly, and then it got into my if statement because it was hungry, and we fed the dog. What if we have something like this? Public function is full, and that's going to return a Boolean. And my condition for full is the logic that we already have in place. So it's the food in belly is equal to 5. So now I can tell if my dog is full. And down here, instead of an if, I can say something like this: while the dog is full, or while it's not full, we're going to feed the dog. And then we'll dump the dog before and after feeding it. So let's run this again. And now you can see starts off with no food in the belly. And because of this while loop, now we have a full dog. So that's just a little bit about encapsulation. And ideally, you want things like this, where maybe there's business logic that belongs to the class, and we don't want to expose that outside the class. What does it mean to be hungry? What does it mean to be full? What we want to expose are either methods or properties that make sense outside the class, like feed and isHungry and isFull. And to control that access, so far we have 2 keywords. We have public and private. There's another keyword that we'll talk about later on when we start talking about inheritance and extending classes and things like that, and that's called protected, but we're not going to cover that here yet.